Hello everybody, welcome back to this new WeeW episode for the STM32F1 tutorial timer series. And today, using all what we have learned in the previous tutorials, we are going to set up a driver for this distance sensor called SR04, and we are going to display the data within this LCD. But here is a better view of this LCD so we can see a better picture of it. And as you can see right now, we do have around 150 centimeter. This is the width of my room. But if I put an object right here, and you can check here again the scale, we almost measure the same distance and that the scale, so which is perfect. So if you'd like to learn how to set up a driver for the SR04, just follow this episode. Within this video, we are going to gather all the knowledge we had within the timer series to build a driver for the distance sensor SR04. All the code that we are going to build together is available on GitHub. You just have to follow this video, understand what's going on, then download and play with the code. The language that we are going to use is only C. The program to code is Scale version 5. The level of this video is a WeeW level, which means that if you want to understand really at the root level what's going on in the code, you may need to go back to the videos where we start building all the functions. But if you just want to use the function that we have to play with this distance sensor, this is perfect for you. From the hardware perspective, we are going to use the STM32F1 based board, or aka Blue Pill. We will need the HC-SR04 distance sensor, a 4A battery to have the 5 volt, and also we will make some display. So we are going to use a 1602 LCD screen plus the I/O extender, the PCF8574. We do have a special video for this one and how to make the setup. So if you are interested, you can go back to the STM32F1 series and have more understanding about how it works. Okay, let's take a look to the tutorial. First of all, we need to understand how this sensor, the HC-SR04, is working. Then we will have a review for the circuit. After that, we will have a startup code, so we don't need to write all the code that we don't need to focus on. So I will go through an explanation of the startup code and what is doing. Then we will set up the driver, so with a normal way, how most of the people will set up the driver for the HC-SR04. And finally, we will set up the driver, but a much better way. And this is the way where we use only the timer and reduce the computing power, just having a very efficient code. Okay, so let's start and take a look to the HC-SR04 sensor. So this is the sensor that we do have here, and you can see there is 4 pins. So for the wiring perspective, we do have this 4 pins, which one of them is 5 volt supply, so you can give it 3.3 volt, and that's why I'm adding the battery. And after that, we do have the trigger pulse input, and we will see later on how to work with that one. Then the third one is the echo, which is the output from the sensor, and finally the ground. So how this sensor is working? So first of all, we start by triggering the sensor and sending an input from the microcontroller with a certain limited time, and here it's 10 microsecond, and give this pulse to this sensor. After that, what's going on? The sensor will use this trigger input to start measuring the distance, and this is by sending some sonic burst and computing how long it takes to come back. And finally, we are going to start reading the data, and this is coming from the echo pulse output pin, and it will send a TTL input TTL lever, and the length of this TTL will be the distance. But before we jump to the formula of how computing from this length of the TTL input to the distance, you have to spend 60 milliseconds between 2 cycles. Then finally, for the formula, you take the input TTL in microsecond and you divide by 58, you get the distance in centimeter. It's quite simple, and the operation can be quite easy and done by simple GPIO and a delay function. Okay, so let's take a look to the wiring now. So first of all, as usual, we do have our STM32F1, and we are going to connect our LCD screen. And here you see our I/O extension board. So we are going to connect using the PB10 and PB11 for the I2C communication, plus 3.3 volt and the ground. After that, we are going to put our SR04 and preparing our battery. So here, don't forget, and this is extremely important, to connect the ground of the STM32F1 to the ground of the battery. This is important, so when the sensor starts sensing, it have the common ground. After that, we are going to power this SR04. Then we are going to use the PA08 as a compare and PA9 as a capture to connect respectively with the trigger and the echo. So this is our circuit. So now let's go and start understanding our initial code. Well, this is our initial code. So first of all, let's take a look to the libraries. We are going to include the timer drive, which is a library that we are going to use later on for set up the driver. Then we do have the SysTick time, which will be used for the I2C library, which is actually used in the I2C drive. And this LCD1602 drive is a library that will allow the display. And finally, the help function, which will be used to compose and to structure our message. Okay, so first of all, we are going to initialize the SysTick init. Then initialize our LCD I2C, and this one will prepare the usage of our LCD display. Then we do have these two functions. So the first function is the LCD I2C message. Here we are going to use the I2C2 peripheral. Line number 1, we start at 0 position and we write welcome to the. And after that, the second function, which is exactly same as the first one, will be using I2C2. And in the second line, from position number 6, and write WeeW. We will wait 1 second, and this is just to see well the display. And after that, we will start putting the same, using the same function, but putting distance and dash centimeter. And after that, 0 here, because we don't need any display. And if you go inside the while, there is nothing to see, but just we will be using it later on for the continuous display. Okay, so this was our code. Let's take a quick look also to the circuit that we do have. So this is our circuit as we discussed. This is our LCD display, which is connected to the I2C2 peripheral of the STM32F1. On the other hand, we do have the 5-volt battery, which is here and connected to the SR04 5-volt and the ground. And you can see here, this is the ground of the battery, which is connected to the ground of the STM32F1. Finally, we do have the PA8 and PA9 that we will be used respectively as a trigger and as an echo for the SR04. I added a small scale, and this is later on to be sure that we are measuring the right distance. Okay, so what we can do now is to run our code and see what's going on. So let's save, build, and let's load it, see what's going on. So we do have welcome to the WeeW, it went quite fast, and then we do have distance, and we are waiting. And you don't see it here well. Let me try to zoom on it. No, I can't zoom, unfortunately. Okay, it's zooming a little bit. Can it go? No, it can't. But you do have centimeter here, which is exactly what we wrote here. Okay? Perfect. So now we understand our code. We understand our circuit. So what we need to do next is to start making a driver for the SR04. So this part, we are going to build the driver for the distance sensor, the SR04, using the traditional way, so which is using GPIOs and also some delay function. And let's jump quickly. So first of all, we are connecting the trigger and also the echo on the P, respectively PA8 and PA9. So what we need to do is a digital output for the PA9. So here the port A, pin number 8, it will be a digital output. So this one, and like this, because we are going to trigger with that. And after that, we are going to use the digital input for the PA9, sorry, which will be the echo. And this is the one that we are going to receive to get the data. Then after that, what we are going to do is start first of all by put the GP right. So, or actually it's write GP, WGP, and this is to put write GP. And for the PA8, we are going to set it at high. Okay, we are going to wait for a few microseconds. So delay, actually it's timer delay, and we are going to put it in micro, like this, timer delay micro, and we are going to wait for 10 microseconds. Okay, and after that, what we need to do is the write GP, and we are going to put it low. So PA8 low. So here we have trigger it. We put the trigger, and the SR04, we start measuring the distance. So after putting the trigger and preparing everything, what we are going to need now is to play with the echo. So first of all, we have to count here while the echo is not high, means the SR04 is still counting. So here we are going to use while the read JP for the PA9, so this is our input, so is equal to 0. So while it's equal to 0, we just wait. And after that, when it finishes, so when we end up this while loop, we are going to start here. So the timer, we call the timer start here. Timer start micro for T4. So we are going to use the timer number 4. And we are going to start reading. So here, waiting until it's so this one means it's equal to 0, but now let's GP. So while, yeah, and also I need to put the period, which I put 65 millisecond. Okay, and after that, so while here we count our GP. So again, the read GP, and as far as it's still high, so PA9 is still high, we keep waiting, just waiting. Okay. So something, yeah, I forgot a parenthesis. So after that, immediately after that, what we need to do is and we need to get a variable. So let's call it my capture time or my distance. Let's put my distance here. So int, here my distance equals 0. So the distance, as we have said, is the time divided by 58. And to get at that, so let's put my distance like this. That will be equal to, and that will be get the function where we put it, get the time in micros for the timer 4, because we initialized here, so we do have a timer running on, and this one divided by 58, and this is the formula we have been seeing in the slide tutorial. Okay, so we do have that, but immediately after getting that, we need to go for a delay function, a quick one, of milli, and we have to wait for 60 milliseconds to get in the next cycle. Okay, that's perfect. But after that, there is a very important part, which is the display. And to make the display, we will need to play a little bit with some variable. So let's add those variables here. So we will have the first one, the int here. No, it's actually both are string. So char, we call it my int, or the string that will be converted to the int. And here it will be a 3-digit only a string because we don't need it more, as the sensor goes up to 8 meter, which is 800 centimeter. Okay. And also, we will need another char for the display, and this is to adjust or correct the lag between the numbers that we will have. You will understand when we start the project. So display, and it will be using 3 also digit. Okay, perfect. So my display. So what we are going to do, first of all, is to use the function from the help func, and this is int to char. This is the function we created together in previous video, and we are going to take my distance here, where is the my distance variable, and we are going to insert it in my int. Where is it? It's a my int. Okay, without the my int. Okay, so here we converted the integer, the integer to a string. But after that, we need to play a little bit with the if condition. So if here my distance is less than 10, so if it's only 1 digit. So what we need to do here, and this where we need to have our display. So we will have my display here. So my disp. Why it's call it just disp. I'll call it my disp is better. My display of 0 here will be equal to just a space, and also my display to 1 will be equal to space, and finally my display of here 2, it will be equal to my int to 0. Okay, because it's only 1 digit. And let's copy this one. So before that, what we would like to have is to use this LCD function here and put it here. And so as we do have this distance, we would like to start from here, and that's why we put it this one empty, and here the number. So we are going to start from 9 and remove all this and put my display here. That will be displayed. Okay, so that's why we needed to make this small transformation. And then else, and let's put this one again, if it's less than 100, so which means I need to put my int, the 0 digit here. Let's put it, this one will be 0 and this one will be 1. And finally, else, if it's greater than 100, it will be much simpler. We don't need to make any transformation. We just have to put my int here and not my display. Okay, and at the end, a very important step is to always erase or empty the my int string. So string empty my int. Okay, so that will be a clean again string that we can keep using again and again. So first of all, so there is 2 steps in this tutorial. The first step is reading the data from the sensor, and after that make the right and clean display. So let's save and build, see how things goes. Okay, 0 error, 0 warning, perfect. So let's go here. So we do have here our distance. So I put it as care here so we can check if we are good or not. And as you can see, this is not a very clear picture that you do have. So I added this one. So let me first load the code to see what will be going on. So let's load the code here. So now, welcome, and we do have some values. So you can see here, we do have, this is the length of my room. Unfortunately, it's a very narrow room. And let me try to put something on the way so you can see that's changing. And I'm moving here. So you can see the more I move here, the more I move, there's a distance change. Okay, so you can see there's no issue. Actually, there's one issue. So why here? That's what I didn't want to see. So you can see there's a number here coming on, which is not what I'm expecting to see. So you see 43 here, and I should not see 43. So instead of doing here my int, what we can do is really keep using only my display, which is a clean one. So we put it here, and we are going to put this one like this. So this is 1, this here 1, and here 2. That will be correcting the problem. Okay, and let's put here. So we do have in centimeters. So let me hide this one for the moment, like this. So by putting this one here, you can see that the number is decreasing based on the distance. So I'm using the pocket of my glasses here that I move slowly. And you can see the more I get near, it can be corrected, the offset can be corrected, but it's exactly what I'm expecting. So here I do have between 5 and 6 because there's a small offset here within the distance of the scale. But as you can see, so if I can move a little bit more when we get here and we get further, the distance change accordingly. So we do have now a code that is working properly and displaying, but this is a normal code and we are wasting a lot of cycles here. So in the next part of the episode, we are going to take a look on a more efficient and more simpler way to run this distance sensor. In this new part of the code where we are going to optimize all this operation, let's first start by commenting all this part as a normal code, and we are going to start to implement the more efficient one that will be using purely the timers. Okay, so here we commented everything, and what we are going to use here is the compare and also the capture. So first of all, the output that we are going to have is to use the timer PWM like this, micros, and we are going to use, first of all, the PA8, which is our trigger, and we are going to use it for putting here 61,000 or 60 millisecond, and here we will have a 10 microsecond. So what will happen here is the PA, the port A pin 8, will have a cycle of 61 millisecond, and during those, the first 10 millisecond, it will be high, and then it will go low, which is exactly the same as this one. So here we are saving a lot of computation just by doing this one. So after that, and this is quite, we will do this in 2 steps. The first step, we are going to read here, we put a timer, and we are going to take the capture micro, and we are going to use the port A and pin 9, and exactly same, so 61,000 here. Okay, but we are going to read not the falling edge, this is that we would like to see, but we would like to see the rise edge. Okay, actually, just a moment, I pushed the rise edge here. And so we would like to compute how long it takes to rise. So let's go here, and what we would like to read, so put my distance here, and we are going to read actually the get the capture. This is the function we created in the previous tutorial. So get capture in microsecond. Okay, so for the PA port A9. Okay, so what will happen here? So our microcontroller will send the trigger for 10 microsecond, and then the SR04 will compute the distance, and after that, after a certain time, it will have a rise. And what we would like to compute right here, right now, is how long it takes between the trigger, the end of the trigger and the preparation or sending the data back to the microcontroller. So what we are going to do is save and build. So no error, no warning. So let's load on this one, and let's go to our debug mode and see what's going on. So let's run our code. There's nothing to see within the microcontroller here, but we'd like to see what is the value of my distance. So let's go here and go to the watch, and you will see here, so I'm removing this one. So you see this number here. This is the time that it takes each time when we send the trigger. This is the time between the trigger ends and when we have our first rise. So we can see we do have an average here. It's 470 microseconds. So that's a quite very important number. It's between 64 and 69 and 71. So it should be fine to use the 470. And this number here, we are going to use it to compute for the fall. So let's go back here. So, and what we are going to do, so we are going to take this number here, but we are going to put, so not anymore the rise, but the fall, like this. So we are computing the fall, and this is the whole distance, but it will be minus the 469. We take the minimum just in case. So if we take this one, it will give us exactly the length of the period that has been all high. And we divide the whole thing by 58, which will give us the distance. So let's save, build. So, which is good, no error at all. And let's load. So, and let's go back to here to see what's going on our distance. So we do have our distance here almost as the previous one. It's much faster, much accurate, because this is working within the same cycle. And if I put here some object, it starts computing immediately. And you can see it's much easier, and this is more accurate because the cycles of computing, there's no delay, there's no issue, and we do have the right value. And you can see here, it's just, so if we hide this one, it's only one line, and nothing is happening within the microprocessor without. The only thing is here, the computing the distance, but all the rest, we don't waste any cycles. So if you can see back here, we are not wasting cycles in delays in while doing nothing until this is high. And this is extremely useful if you are using more robotics or control system. So your reading is much faster. You don't need to waste cycles of your microcontroller just for waiting. Okay, so we do have our function. So what we need to do right now is just to put the whole thing in the function. So let me close this one and open the timer. Here, where is the timer? Well, let's open this one and this one. So we go to the timer part and let's start building it. So that will be a void. We can put init, the init SR04. And we will need to have char, and this one we call the trigger pin. And then, yeah, so we can put same port or trigger pin. I think we need to put the port, char port, and trigger pin, and also char. Still, we need to put the port, unfortunately, and also echo pin, char echo pin. Let's put it like this. Okay, so what we have to do right now is quite very simple. So char, for this one, port, let's call it port 1, and no, like trig. Let's have more meaning in our writing. And for this one, echo. Okay, so what we need to take, to initialize is really simple, as you could see here. So let's take those two functions. What we need to put here is our trigger port here. So it will be the PA like this, and the trigger pin is the 8 on this one, where on the port echo, so that will be the port for the echo, and after that the char for the echo pin. Okay, so that's all. And finally, if we would like to make another the one to get the value, so let's make this one clean like this. So int is get distance like this for the SR, or let's call it SR04 distance, or get value. Yeah, depend on the name. I'm lacking inspiration now. And what we need to get here is the port and the pin. So we call pin and value. So pin, so char port and the char pin. So we don't need to waste time on this one. So it will be quite simple. What we are going to use is the same function here. We call int my distance like this, int my distance, and that will be equal. So what we are going to use here is port and here pin. Okay, and what we need to do is return my distance. Okay, perfect. And here we do have our driver, which is extremely efficient. Without using any delay function, we do have quite a good reading. So let's add some space, put this one, and add some space. And so I would change a little bit the name so to have some consistency. So SR04, we call this one init, like this. And then the SR04 get value, just to be consistent and easy to find it with the helper. Okay, let's put this one here, and then we get this one. Okay, that's quite brilliant. So we can go here now and put the SR04 get value, actually the init, and we would like to have the PA8 as a trigger, PA9 as the echo. Okay, and here my distance will be equal to get, now actually SR04 get value, and it will be the PA and 9 like this. And should be good. Let's add the space at the new line at the end here, and also at this one, so which is already here. Let's build. Okay, 0 error, 0 warning, perfect. Let's load and see what's going on. So this is our distance here, and if I put an object, my sensor works properly without really wasting any computation time, which is really great, and this is what we needed. Okay, with this one we complete our timer series, and you can see how powerful the timer can be. I hope you enjoyed the whole STM32F1 series. Appreciate your dedication. Thank you a lot, and see you for the next series. WeeW!